Hey everybody, in our last video we talked about some terminology from the Safety Management Manual by ICAO. We defined things such as hazard, unsafe event, and ultimate consequence, then we transfer them into a visual representation. Well, today what I would like to do is to help you with that visual representation to understand what the safety risk assessment process looks like in the overall safety risk management process. So let's go ahead and jump into that today. All right, welcome back. If you remember from our last discussion, and I'll link that video up here and in the description, is that we arrived at this really cool looking graphic that represents the escalation of loss of control in flight from the hazards on the left, or the causes of the airplane upsets, but are therefore causes of loss of control in flight, as they escalate from left to right through this funnel, resulting in the fatal loss of control in flight accident on the far right in the middle. Along the top, we had the layers of upset prevention and recovery training, including awareness, prevention, and recovery. And then along the bottom, we had the layers of risk mitigation established by the industry. And as we looked at this, I reminded you that this robust system of mitigation perpetuates loss of control in flight as the #1 threat to air safety. And you can see there's even a vertical orange bar at the airplane upset, which is really representing the industry's effort at upset prevention and recovery training, yet it's not making any difference, because to really make a difference, we have to implement a paradigm shift. So before we talk about what that paradigm shift is, we need to fairly look at the system right now based on the statistics we looked at, where loss of control in flight represents nearly 50% of all fatalities in aviation, no matter where you look. So from this diagram, let's go ahead now and do a safety risk management, or risk assessment, I should say. So in the bottom right, you can see the safety risk management process. We start with hazard identification. We eliminate it if we can. If we can eliminate the hazard, the associated risk goes with it. Then we want to move to safety risk assessment, which is what we're going to do here on this video. Then in a future video, we're going to go ahead and get into safety risk mitigation and then reassess the risk at the end of that process. So here's what a loss of control in flight risk assessment looks like. So we're going to pull this chart out of ICAO Doc 9859, and this is a fairly standard representation of a risk assessment matrix. You can see along the top is severity, and so you have your columns from severe, which is catastrophic, and then hazardous and so on from left to right, and then probability is from top to bottom, where frequent is the most prevalent to the bottom, extremely improbable. So when we're assessing risk, we want to figure out where the risk lands on this particular chart. So the escalating risk results in loss of control in flight. So the loss of control in flight risk is assessed here based on the outcomes. So as we look at it, we take a look, well, where does loss of control in flight live on severity? Well, it's almost always fatal and or catastrophic, so it clearly lives in the catastrophic column. The real question is, well, where does it live on the probability side? Because I want to remind you what those squares mean. The red color squares, and then the orange color squares and the green color squares represent the safety risk profile of this particular operator. Red is an intolerable risk. If we land on a red square, we need to cease the operation, mitigate the risk, and reassess it. Okay, so ideally we'd like to be in the acceptable risk, or the green area, because that is an acceptable area of operation. If it identifies in there, gets mitigated to that level, then you can continue the operation, all right? The orange one represents a tolerable risk, and that requires mitigation and or management decision to move forward. So let's get back to probability. Let's look at the definitions of some of those columns. So in probable, the second one from the bottom is defined by ICAO as very unlikely to occur, not known to have occurred. Well, we know that's not true about loss of control in flight, because not only does it occur, it occurs more than anything else and is responsible for 50% of all the fatalities in most parts of aviation. So let's go up to remote. Under remote, it's defined as unlikely to occur but possible, has occurred rarely, 1 per 5 times per year. Now, that is sounding more like it. If we remember back to the statistics we looked at a few videos ago, business aviation, for example, in the United States, over the 10-year period we looked at, had 20 fatal loss of control in flight accidents. So it's certainly this. Let's go to the occasional level. Reasonably probable, likely to occur infrequently, 1+ per year. Now that actually sounds more like business aviation, for example, that we were talking about. But let's not overstate it. Let's not over-dramatize. Let's go to remote. I think that's a balanced way to approach it. But look at where remote lives. We're under the catastrophic column under remote. A value score of 15, which is an intolerable risk or existing risk, lives right there, which by definition means we need to cease the operation and mitigate it. So that's based on the existing training system, the existing certification, the existing type rating, is that loss of control in flight, by the true nature of risk assessment, really is still a massive threat to the aviation industry, more than anything else. So the goal of this particular process, as we go from safety risk assessment, which is what we just did, we're landing on that square, the ideal safety risk mitigation is we like to drive down both probability and both severity, which is usually fairly unheard of in risk mitigation. Usually it's one or the other, not both. But in the term upset prevention and recovery training, it's telegraphing what both are. So for example, in upset prevention, that's what drives down the probability. So for example, APS partnered with Delta Airlines. They did a 5-year, 5 million flight study, and they saw the partnered UPRT program with APS at Delta Airlines drove down their risk exposure by 50% to precursor upset conditions. So that's pushing the arrow down in probability. Now on the right side in severity is how effective are pilots at recognizing, preventing, or recovering from a developed or developing airplane upset event. And so United Airlines did research with APS, for example, a 3-year study, and they saw that the ability for pilots after an effective upset prevention recovery training program like APS had an increased competency of 400% above than when they started the program to the end of the program. So it is very achievable to do this, although it requires very specialized, targeted, proven training to accomplish it. But done right, our risk mitigation should be able to drive us down from a intolerable risk all the way through tolerable into an acceptable risk. But it takes intention, it takes expertise, and it takes a paradigm shift in how you implement upset prevention and recovery training. The industry very well knows what to do, it just knows not how to do it. And in the next discussion, the next video, we're going to talk about where the how to do it lives.